Okay, let's take a look at lesson 8, factoring by decomposition with a GCF, with the greatest common factor. So remember that when we want to factor, we always want to try to find a GCF first, okay, a greatest common factor. So that always makes our life much easier if we can remember to try to factor out whatever number will come out of all of the terms of the polynomial. So, and then of course the first step is to find two numbers that have a sum of b and a product of a times c. So for example, let's just review this down here. When I look at this, this is in the form of ax squared plus bx plus c. And so I would want to find here a product, right? Because a is 2 and c is negative 12. We want to find a product of 2 times negative 12, which is negative 24, with a sum here of positive 5, right? We want the sum of positive 5. So which numbers here, if I multiply 1 times 24, 2 times 12, and 3 times 8, which of those could make a negative, or I guess we can have 4 times 6 also, which of those would make a negative 24 and add up to 5? Which of these could add up to 5? Well, 3 and 8 could add up to 5. One of them would have to be negative, which is what we need anyway because we need a negative product. So we know here by looking that we need a negative product. So the 8 would be positive. We need the bigger number to be positive because we need a positive 5. Okay, and then there's our negative 3. So depending on how we set that up, we're going to draw our little box over here. Okay, and there we go. And of course, let's fill this in. We've got our 2x squared, and our negative 12 goes here, and 8x and negative 3x can go in either one of these boxes. Okay, now let's factor by grouping, or factor by looking at the rows and the columns for the greatest common factor. If we go across here, we've got 2x squared and 8x, which gives us a GCF of 2x. And continuing along, remember if there's a negative here or in this box, those negatives come out. Okay, so we indeed do have a negative here. So we're going to take out a negative 3 because 3 comes out of both 3 and 12. Looking down at the columns, 2x squared and negative 3x. The only thing that's common there is a common x. And looking down at 8x and negative 12, we've got a positive 4. We'll go into both of those. So there we are. We've got our factors. And I always want to remember that I want to put that equal sign down so I don't forget that what we're saying here is this statement here is equal to that statement above, which it indeed is. So I've got a 2x minus 3 and an x plus 4. Alrighty then, let's look at the next one. The first thing I would like to do when I look at a question like this is I want to rewrite this in descending order. My 20c squared, okay, minus 41c plus 9. There's our polynomial rewritten in sort of the more traditional order, right? And there's our ax squared plus bx plus c. Here c is just our variable, okay? So I still need a product here of 20 times 9, which is 180. And a sum of negative 41. So these are a little bit bigger numbers, but that's okay. So I know 1 and 180, 2 and 90, 3 and 60, and I would just get out my calculator and start plugging those in, right? 180 divided by 2. Well, that's probably pretty easy, 90. 180 divided by 3. Okay, 180 divided by 4 is not 5, 45. Whoops, sorry. And 180 divided by 5, I believe that's 36. 180 divided by 6 is 30. Okay, 9 goes 20 times. 10 goes 18 times. I think 15 goes in there. I'm just doing this in my head. Sorry. 180 divided by 15. So I would, like I said, I'm literally going to get, 15 and 12. So 12 and 15, okay? I think that's all I can do. 20, of course, would go in there. 20 and 9. Okay, I hope I haven't missed any, but I think that's about as far as we can go. So now that I've got that, I need a product of 180, which adds up to negative 41. So which of these could add up to a negative 41? Ooh, and by the way, oh yeah, sorry, we need a negative 41. I almost thought it was 40 and 44 and 45, but that's not going to work. Let's look at these two. So this is one of those tricky ones. Well, it almost looks like we have two possible answers, doesn't it? Let's just take a look and analyze these. We've got 4 and 45. I could make that into a negative 41, couldn't I? We could make that, let me just erase that a little bit. We could make a 4 and a 45 into a negative 41 if this was a positive and this was a negative. But then if those were positive and negative, I would end up with a negative 180. And I need a positive 180 because I've got a positive 20 and a positive 9. So that has to be positive. So I know that those two factors don't work. Now let's look at 5 and 36. Could I make a 5 and a 36 into a negative 41? Sure, if they were both negative, and two negatives make a positive. So I really had to think about that one. And that my answer is, my proper terms are negative 5x and negative 36x. So let's again draw our box. The hard work is figuring out which terms to plug in, isn't it? And once I've got that, from there I can always do the rest of the factoring quite easily usually. It's just I have to make sure I have the correct terms, and if I don't, then everything's going to be incorrect. Okay, so let's plug those in. What do we have here? We've got a 20c squared and a positive 9, and then this would be a negative 5c and a negative 36c. So now when I factor going across here, I'll start with going across 4c squared and negative 36c. So I know that, sorry, 20c squared and negative 36c, I was going to say that 4 will go out of both of those. Okay, 4 and a c, 4c. And remember to double check your signs. That looks good. Going across here, this negative means I'm going to take a minus out. 5c and 1 is 5c and 9. The only thing that's common there is a 1. So I'm going to take out that negative 1. And then going down vertically, 20c squared and negative 5c. Again, this negative doesn't come out because it isn't common to both of those. It only comes out if it's here or here. So 20c squared and negative 5c. A positive 5c can come out of there. And then this is a negative 36c and 9. A 9 can come out of both of 36 and 9. So when I multiply that out, or sorry, rewrite out my factors, we get 5c minus 9 and 4c minus 1. Okay, we can always do a check if we want that those look like to be the same, the proper factors. Okay, so let's take a look at the next example. It says determine a possible value of b so that each trinomial can be factored. So if I look at a question like this, this is one that it really helps to understand what factoring is. So if I want to factor this x squared plus bx plus 10, this basically means what numbers could go in for the position of b to make this a factorable question. So I know that I'm looking at factors of 10. I would need a product of 10 with a sum of b. So what numbers could give me a product of 10? So it's really all based on the product of 10 here. And if I can figure out those factors, what would those be? I can multiply a 1 times a 10 or a 2 times a 5. Those are the only two whole numbers that will give us 10. And I know that I could have a negative 1 times 1 and a negative 1 times negative 10. That would give me a positive 10 as well. So these could be plus or minus and plus or minus. So therefore our b value could be product of 10 that adds up to a positive or a negative 11. Okay, they would both have to be negative or both positive to get that positive. So if I had a negative plus a negative, I would have a negative 11. Positive plus positive would be a positive 11. And then also I could have a sum of plus or minus 7. So our b value could be plus or minus 7 or plus or minus 11. Okay, those are our our four possible answers there. All right, for this next question then, what we're looking at is we're kind of going backwards. In question A, we had to look for factors of 10 that added up to B. So we had the factors. For this next question, we need factors of 6 times B. Okay, we need factors of 6 times B, whatever B might be, that would have a sum of 17. So here we know the sum is 17. So what I can do is I can say, well, what numbers give me a sum of 17? Let's pick some more obvious ones. Now, there's actually infinite answers here because we can have negatives as well as positives, right? I could have, a -1, a -1 plus 18 is 17. But let's stick with the positives. Let's stick with the positive numbers just for now. So, for example, 1 and 16 add up to 17. Okay? Or 2 and 15 add up to 17. Or 3 and 14, and so on. We'll just do a couple of them, okay? And if I take these sums and then find the product of these two numbers, for example, 1 times 16 would be 16, 2 times 15 would be 30, and 3 times 14, I'm just using my calculator here. Well, my calculator in my brain, but you could use your calculator. Okay, 4 times 13 would be 50, what's that, 56? 52, sorry, 52. And then 5 times 12 would be 60. So then I want to say, are any of these products, could I make any of these products have a factor of 6 times something? Okay, well 30 has 6 times 5. So I know that would work. 6 times nothing can work out to 16. 42, is 6 times 7. Okay, so 52, I don't think there's anything that multiplies by 6 to give me 52. But there's, of course, to get 60, I know that 6 times 10 would equal 60. So if I look at these numbers, all of these numbers here, the 5, the 7, the 10, and there would actually be a whole bunch more, okay, if we were to keep going with these sums here and these products, that we could find numbers that would add up, that would make this a factorable question. So what I know here is that B could be 5 or 7 or 10 and so on. There's a few of them right there. So here, for example, let's put in 5. We just do a check here. 6y squared plus 17y plus 5, right? I'd be looking for a product of 30 with the sum of 17, right? And of course 15 times 2 will give me 30, and 15 plus 2 will give me 17. Okay, so that's just a bit of an example there. There's a few of our answers for that one. Let's turn the page. Let's go to the next page. It says factor the following trinomials where possible. So the first thing I want to do in this lesson, and really anytime I'm ever factoring, the first thing, if you can remember this, then you are going to be the golden, most amazing factorer. Okay, we always want to try and take out a greatest common factor first. So remember the first kind of factoring we did where we said what's common to every number? So I'm going to look at 2 and 14 and 20, and I want to see what number will come out of all three of those. Well, if I look closely, they're all even, and a 2 will come out of all of those. So I've got 2, I'm dividing out my 2, right? That's my greatest common factor, minus 7x plus 10. So then what I want to do is I'm looking for factors of 10 that add up to -7. So let's make our little box over here. We always want to then try and factor our trinomial if we can. Okay. And if we do that, we get, let's just plug these numbers in. I've got a 2x squared and a 20. And of course, factors of 10, I need a product of 10, right, with a sum of 7, -7. So what numbers will multiply to give me 10? Either 1 and 10 or 2 and 5. And I need a positive 10 and I need a -7. So if I need a positive 10, the only way I can get a positive is by positive times positive or negative times negative. So because I need a negative sum here, I know both of these have to be negative. And negative 2 plus negative 5 is negative 7. And negative 2 times negative 5 is positive 10. Oops, and this should be here, sorry, Mrs. Schwartz. We have to take our factored one here, okay? This is x squared, and this is 10. And then this is, of course, negative 2x, and this is negative 5x. So if we go across there, x squared and negative 5x, what's common there? Well, an x is common. Negative 2x and 10. Remember this negative here, we're going to take that right out. So that's a negative, and 2 and 10, 2 is common to both of those. And then same here, this negative is going to come out. When we go across, or sorry, down rather, x squared and negative 2x, x is common. And my minus is going to come out, and 5 and 10, 5 can come out of both of those. That's my common factor. So when we end up here with our next row, we get x minus 5 times x minus 2. And we have to remember to put the 2 in front, or technically it's incorrect. Okay? Let's try the next one. Greatest common factor. Sometimes our greatest common factor is simply a number, like the prior question where it was a 2. If I look at these, we've got a 4, a 16, and a 20. I know that 4 comes out of all of these. And x to the power of 4, x to the power of 3, x to the power of 2. I can take an x squared out of all of these as well. Right? I can divide out an 4x squared, a 4x squared, and a 4x squared. Okay? And when I get that, my leftovers are 4x squared divided by 4x to the power of 4, rather, divided by x squared is x to the power of 2. 16 divided by 4, that's a negative, so it's going to be a minus 4x, because 3 divided by x cubed divided by x squared is x. And negative 5 by itself, because the x squared divided by x squared is just equal to 1. Okay, and now again, I still need to factor further. I need to take this trinomial, I need to create the box, and let's fill it in here. And when we solve this, let's fill that in. We get x squared, right? Minus x goes over here. And I need a product of negative 5. My product is negative 5 with the sum of negative 4. So what multiplies to give me 5? Only 5 and 1, but I need a negative 4, so therefore this has to be negative and this one has to be positive, right? And that will multiply to give me a negative 5, which is what we need there. Okay, so let's plug these other guys in. That's a negative 5x and a positive 1x. Okay, going across, x squared and 1x. X is common. Going across, negative 5 is common. Negative 5x and negative 5. Going down, x squared and negative 5x, that's an x that is common. And going down, again, 1x and negative 5. Just 1 is common. That's the only thing that's common there. I can't take anything else out. So therefore, our two factors here are x plus 1 times x minus 5. And don't forget the GCF. That gets copied down as well. Okay, so there's 2 more questions here. I think, why don't you give it a pause and try these questions on your own and see if you can get the same answers. Okay, so hopefully we remember to take out that greatest common factor, which in the first question was 2, and in question B was 5x squared. And there would be your answer. Once you take that out, we factor the trinomial, and away we go. Okay, so if you need to pause the video and check your work, that would be fine. The last one says factor 6n squared minus 21mn plus 45m squared. So this is one of those with the 2 variables. We don't have to panic about that too much, but I still want to do the same process. Always, we take out our GCF first. And what's common to 6, 21, and negative 45? Positive 6, negative 21, and negative 45, I should say. For sure, it is a 3. A 3 can come out of all of those. So we're going to divide everything through by 3. And we end up here with a 3 out front. And we get a 2n squared. 21 divided by 3 and minus 7mn. And 15 divided by 3, negative, that's negative 15 m squared. Now, let's continue, and I'm just going to do that little chart. Okay, we still just want to plug in those values and see if we can factor thoroughly. So we've got a 2n squared, a negative 15m squared, and then so that's a product of 30. Right, we want a product of 30, negative 30, because it's negative 15 times 2. Right, we want a product of negative 15 times 2, which is negative 30, with a sum of 7. So what numbers multiply to give us negative 30 and add up to negative 7? I'm just going to move this down here, or up here, so you can sneak it out of the way here. So to get negative 30, we can multiply 1 times 30, 2 and 15, 3 and 10, 5 and 6. I think that's it. So if I look at these numbers, which ones of these could add up to negative 7 and make a negative 30? Well, that would be 3 and 10. Okay, I need a negative 30, so one of them has to be negative, and I need a sum of negative 7. So my negative has to be the bigger number. So that's going to be a negative, and this is going to be a positive. Minus 10. So normally we would just put down 10x here or something like that. This is going to be a minus 10mn and a positive 3mn. And then when I factor, going straight across, for example, 2n squared times negative 10mn, well, 2 and n is common. 3mn and negative 15m squared, well, 3 and m. So it looks like one of our factors is 2n plus 3m. And if we go down, 2n squared and 3mn, looks like an n is common. And negative 10mn and negative 15mn, it looks like we've got a negative 5m. So when we continue here, we get 2n plus 3m and n minus 5m. Okay, that little m just kind of gets tacked on there on the factors. But if we were to do a check, I would leave the 3 out, and I would first FOIL, and I would get my 2n times n, which would be 2n squared. And then, of course, a minus 5m times 2n would be a negative 10mn, a positive 3mn, and a negative, right, positive 3 times negative 5, a negative 15m squared. And then, of course, if we simplify or combine our like terms, that's a negative 7mn minus 15m squared. And finally, if we distribute that through, that 3, we would get a 6n squared minus 21mn minus 45m squared. Okay then, so there's lesson 8, and for that lesson, I would assign the following. I would say number 1, odd letters. Number 2, BD. 3, BD. 4, BD. And number 5. Okay, good luck with that, and please don't hesitate to contact me if you have any questions or concerns with your homework. Thank you.